is Chapter 7, Section 2, Inverse Function. The definition of a relation is a set of ordered pairs, x and y. The inverse of a relation is interchanging the ordered pairs. So here's an example. There's a set of 4 ordered pairs, 1, 2, 2, 4, 3, 6, and 4, 8. First thing, is this relation a function? Does it pass the vertical line test? Yes, it does, and we'll show you that on a graph below. What's the inverse of this relation? So we take each of these blue ordered pairs and we interchange them. So the interchange of 1, 2 is 2, 1. The relation of 2, 4, its inverse is 4, 2. The next one then, when we interchange it, is 6, 3. And the last one is 8, 4. Is the inverse a function? Does it pass the vertical line test? Yes. So what we're going to do next is we're going to graph each of these ordered pairs on the same plane. So the first ordered pair is 1, 2. So we'll go over 1, up 2. So there's ordered pair 1, 2. The next one is over 2, up 4. And the next one is over 3, up 6, and then over 4, up 8. So the 4 ordered pairs represent a relation. Then let's graph the red ordered pairs, which are the inverse of the relation, the blue ordered pairs. So now we'll go over 2, up 1, over 4, up 2, over 6, up 3, over 8, up 4. There is a line which we call the inverse line, the identity. If I create these ordered pairs here, about the line y equals x, what happens is the blue and the red ordered pairs are reflected about this identity line. The identity line is a slope of 1 and a y-intercept of 0. So part of your homework today is we will give you a set of ordered pairs and you need to find its inverse. Just interchange the ordered pairs and then you can graph them. Let's go on to the horizontal line test. The horizontal line test, for short, we call as the HLT. A function f has an inverse if and only if no horizontal line intersects the graph of the original function at more than one point. So make sure you write down this definition, the horizontal line test. So here are 2 examples. You don't need to write them down. The first example on the left, the blue and the red are what we're going to look at. If I create a horizontal line through the first example here, this horizontal line touches here and there. So what we say is this example fails the horizontal line test. So what that means then is there's no inverse possible for this relation, this function. Now in the blue is what we're going to see more of in our next example, where if we were to create horizontal lines, this imaginary line, it touches once, touches once, touches once. So this example passes the horizontal line test. So what that means for us is we can have an inverse. An inverse does exist. So that's the difference between these two examples. The first one fails the horizontal line test because it touches more than once. And the blue one passes the horizontal line test because it only touches once in any of those horizontal lines. This next slide, please write down these 4 steps. Steps to finding the inverse of an equation. So what we did in the first slide is we found the inverse of a relation where we had a set of ordered pairs, and all you do is interchange those ordered pairs. Now in an equation we have 4 steps. Number 1 is to replace the function notation with y. Number 2, we interchange the x and the y. So every x becomes a y, every y becomes an x. Step 3 is to take that equation and solve it for y. And then step 4 is to replace the y with f inverse notation. You can only do these 4 steps if the original function passes the horizontal line test, which we call 1-to-1. So if you have not finished writing up these 4 steps, just go ahead and push pause. If you have, we're going to go ahead and move on to our example. Here's our example. We want to find the inverse of this function. So let's just take a moment and graph the function first. So if I replace y with that f of x that we had up there, you'll notice that this is a line. So let's take a moment down below and graph this line. The line is y equals 4x minus 5. So its original function is 4x minus 5. And I just replaced it with y. This is what we call slope-intercept form. It's been a little while since we've done this. So this represents the slope, which is 4 over 1, and this represents my y-intercept of negative 5. So let's go over and graph it. So first thing we graph is the y-intercept, which is negative 5. And now we're going to do our rise over our run. So we're going to rise 4 and run 1. We're going to rise 4 and run 1. Or we can go the other way. We can go down 4 and then left 1. And now let's connect our dots that create our line. This is the function 4x minus 5. If we look at this red function, does it pass the horizontal line test? Yes, it does. So we have an inverse that is possible. So now let's go ahead and find out what that inverse function would be. And we're going to do those 4 steps from the previous slide. Let's come back up. Find the inverse of this red function. So to review for a moment, step 1 is replace the function with y. Step 2 is to interchange x and y. Step 3 is to solve for y. And then step 4 is to replace y with f inverse. Okay, so step 1 we already did. That's replacing the function with the letter y. Step 2 is to interchange each x and y. So now this becomes an x, and that becomes a y. So there's step 2. Step 3 is the longest step, where we want to solve this equation for y. So the first thing we want to do is add 5 to both sides. Then we're going to divide both sides by 4. So the y is now by itself. I'm going to go ahead and break up this fraction into 2 fractions. So I have 1/4 x plus 5/4. And then what 5/4 is a decimal. 1.25. Now the last step is to replace the y with f inverse notation. And now we can go ahead and graph this function below. This is my slope, and this is my y-intercept. So I'm just going to change colors. So we'll graph this in blue so you can tell the difference between the two functions. So below we're going to graph the y-intercept of 1.25, so about here. And now we're going to rise 1 and run 4. Rise 1 and run 4. So here is our blue function. It is the inverse of the red function. So here's your F inverse. Now remember, from earlier in our lesson, the identity function, y equals x, has a y-intercept of 0 and a slope of 1. If we were to create this identity function, look at folding, imagine folding this green line, and you will match up the red and the blue together. They will go on top of each other. This is the finish of our lesson for today. Your assignment for 7.2 is on page 501, 1 through 7, and then 9 through 19 on. Good luck and have fun.